Hello, welcome to today's lesson. This channel is dedicated to providing mathematics to people that are writing their exams, preparing for ECZ exams, that is GCE, grade 12 internal, grade 9, as well as grade 7s later on. Okay, so we are looking at another topic, which is this is the first part of this topic. So in this topic, this is going to be lesson 1, and the way we are presenting these topics, we are following the order, and it is in this same order that we are expecting you also to follow the same topics. That is when you will find them quite easier to follow. So we are doing lesson 1, lesson 2 up to the end of the topic. So I do request that each time you come to any topic, you make sure you go by there. Like this one is going to be called lesson 1. Okay, so now let's look at scale on a map. What is it that is involved here in this topic? This topic is congruence and similarity, but under this subtopic, what are we talking about? Scale on a map. Okay, so we are looking at when you look at the scale on a map, if you look at even the map of Zambia can be compressed on a page, but we know that the map is bigger than that space that it occupies on a page. So it means that it has been defined to some scale. Okay, it has been defined to some scale to say maybe 50 kilometers on the ground. 50 kilometers on the ground is going to represent maybe 1 centimeter on the map. So where you measure 1 centimeter on the map, it means that when you go on the ground, you need to measure 50 centimeters. I mean, 50 meters. That's an example. Okay? So that is the issue that has to be there. The whole world can be put on one page. But if you go on that same page down there, you're going to see a scale. That tells you that 1 centimeter on the map represents possibly 50 centimeters on the ground. So you have to know that. That is just to make sure that we put, even a house, the plan of a house is compressed on one page or on a piece of paper, which is quite bigger than the actual house. So what is working there is the scale. 20 meters on the ground is equals to, or 20 centimeters on the ground is equals to 1 centimeter on the air. So that is what we are going to look at here. But it's very important that even before I begin to explain what is involved here, let me take you through some of the measurements that we are going to find very useful in this presentation. So I'll start with this part. I'm going to start with this part. Let's look at 1 meter. Let's look at 1 meter. 1 meter is equals to how many centimeters? 100 centimeters. Okay? 1 meter is equals to 100 centimeters. Now, if we square 1 meter squared, it means we also have to square this side. To square it means we're going to multiply 100 by 100. So we're going to get 10,000 square meter. So 1 meter squared is equals to 10,000 square centimeters. Please pay attention to these things. These are things that we're going to find very helpful and useful in the subsequent calculations. All right? Then let me come to 1 kilometer. 1 kilometer is equals to what? 1,000 meters. 1,000 meters. That's very important there. 1,000 meters. Okay? Then, what about 1 kilometer square? You square this side here. This side is squared. It means we also have to square these ones. So 1,000 multiplied by 1,000, what do we get? We get 1 million. 1 million meters squared. So 1 kilometer squared is equals to 1 million meters squared. That's very important there also. Then we can come to, I want to look at a kilometer against a 1 kilometer against a centimeter. Against one, how many centimeters, in other words, how many centimeters are there in 1 kilometer? That is what we want to look at. So let's say in 1 kilometer we have 1,000 meters. In 1 kilometer we have 1,000 meters. So again, each meter is equals to 100, is equals to 100 centimeters. 1 meter is equals to 100 centimeters. So to get the number of centimeters that constitute a kilometer, I'm going to multiply the number of meters that are there in a kilometer multiplied by the number of centimeters that are there in 1 meter. So this is going to be 1,000, that is meters, multiplied by 100. So we are converting meters, which give us a kilometer, to centimeters, because 1 kilometer is equals to 1 meter. I mean 1,000 meters. Then 1 meter is equals to 100 centimeters. So what do we get here? We're going to get, what is this? 100,000. This one. So this is the centimeter. That's very important for us to follow there, please. This is very important for us to follow. So then what if we square this side? If I say 1 meter squared, we need to square this number. We need to square this number. We need to square this number. So you multiply 100,000 by 100,000. So how many zeros are we going to have? We're going to have 10 zeros. So this is going to give us centimeters square. All right. This is 10 billion. This is 10 billion centimeters square. So when you square 1 kilometer, then equating it to centimeters, this is what we get. I hope you have followed these things, and these are things that you are going to use. We have to get the understanding of this part, because this is what we are going to use even as we look at these questions. We need to have a way that we apply these things. So if you have followed these things here, okay, if you have followed these things here, then come with me to the actual calculations now. Come with me to the actual calculations, and I hope where you're having challenges, you should be able to reach out to me via the email address, and even the phone number. In other presentations, I've written down my phone number. Okay, so let us look at the first one, a scale on the map. This is the scale on the map. The scale on the map is telling us that 1 centimeter on the map is equal to 20,000 centimeters on the ground. Is equals to 20,000 centimeters on the ground. This is the measurement on the map. This is the measurement on the ground. So we are told that this one, 1 centimeter on the map, represents 20,000 centimeters on the actual ground. All right. Then the actual area of residential plot is 60 kilometer squared. I mean 6 kilometers squared. Calculate the area of the residential plot on the map in square centimeters. In square centimeters. All right. What is it that we are expected to do here? Let's try and pay attention. We have this case. This is a measurement that we are looking for. And here we have 60 kilometer square. So we are looking for x. Now these are centimeters here, and they are not squared. This is a kilometer and it's squared. So what we are supposed to do, what we are required to do is that we need to square this side. And also we convert this one. We need to convert this one. We need to convert this one into centimeters squared so that we have a similar unit. We cannot work with different units. You can't add years plus months. You need to convert years into months or vice versa so that you have got a common unit. Alright? So we are supposed to square this side so that we also have a square. So when you square this whole thing here, we're going to have 20,000 squared is equals to x. Now I'm saying this I have to convert it into, because these are centimeters, so even this one I need to convert it into centimeters squared. Now we said 1 kilometer squared. 1 kilometer squared is equals to 10 billion centimeters squared. So the meaning here is that we need to multiply this 10 billion by 60, because here we've got how many kilometers? 60 kilometers squared. So we have to multiply 10 billion by 60 to convert these kilometers squared into centimeters squared in order to achieve a common unit. So when you multiply, you know that the multiplication that involves this thing, we'll just add these zeros to this number. So we're going to, here we've got how many zeros? 10 zeros, so add 10 zeros here. So here we already have a 0, I'll add another one here. Then now we'll bring these 3 zeros, these 9 zeros. We've got this, and this. Okay? This is 600 billion centimeters squared. This is 600 billion centimeters squared. And this part we have also squared it. Okay? We have squared this part. This has also been squared. Now, this is going to be centimeters squared. Even this one, it is in centimeters squared. Back from this part. Alright? So the next thing that we are supposed to do now is where we square this one. 1 multiplied by 1, it's 1. Over 20,000 multiplied by 20,000, what do we get? Okay? The zeros, we're going to have now 8 zeros here. We're going to have 8 zeros. You have 0, 0, 0, 0, 0, 0. Then what do we get? We have, okay, this is what we're going to get. Okay? This is equals to x over the same. There. Then at that point, it's the question of us, we need to cross multiply. We need to cross multiply in order to find the value of x. Remember what we are working with. These are centimeters squared. We are working with something that is in centimeters squared. Okay? We're working with something that is in centimeters squared. So at this point now, you need to cross multiply. When you cross multiply, you are going to have 400 million x is equals to, we bring this one now, $600 billion. Okay? Then now we have to multiply, to divide both sides by 400 million. So our x is equals to this divided by okay? So what is it that we are going to achieve? What is it that we are going to have here? I'm just trying to work it out. Remember, this is paper 1 where I don't use a calculator. So it's the question of us simplifying. So I'm going to get rid of these zeros here. 3 of them, 3 of them, 3 of them, 3 of them, 2 of these, 2 of these. So what have I remained with there? I've remained with 6,000 over 4. And x is equal to what? X is equal into 6, we have what? 1. Remainder should be 5. Here. Centimeters squared. Everything that we were working with was in centimeters squared. Okay? That is what is expected of us to do. So, once it's the understanding of these units that you need to know here, how do you convert? How do you convert this to the other? I should admit that this part, if a student or a pupil has not well understood this part, sometimes they get to have challenges to get to calculate these things. Okay, so that's very important there. It's very important that we work with these things the way they are written. Okay, so I hope we have managed to follow this one. Let's see if we can consider the second one. I do repeat that, please let's make sure that we get to understand this part. That is where everything lies here. That's where everything lies here. Okay, so we need repetition. Mathematics is about repeating the concept over and over, unless if you are really a gifted, smart person. But if you are an average person, for you to be very good and perfect, or get closer to those that are gifted, you need to repeat the concept over and over until it gets to be part of you. Alright? That is what we are supposed to do. And that is what we keep telling our children in class, that before you do anything, like this same thing that we are looking at today, go through it. Mathematics does not care about the place where you are, the serenity of the place and the like. You just have to, anywhere, even in a noisy place, you can deal with the subject. Okay, you can deal with the subject. So let's consider the second one. I only hope and trust that we are following and we are getting something, because these questions, all of them, I've collected them from different past papers. Okay, I hope if you are going through the past papers, you come into contact with them. So let's look at the second one. A scale on the map. What is the interpretation here? 1 centimeter on the map represents 50,000 centimeters on the ground, and we should be able to convey it. We should be able to convey this. We should not have a problem. If you are converting we are converting a smaller unit. Okay, you are converting you are converting to a smaller unit from a bigger unit. If you are given like 5 meters, convert this to centimeters, which is smaller than meters. You multiply by 100. That will give you what? 500 centimeters. Now, if you are coming from centimeters, which is a smaller unit, to a bigger unit, which is meters, you need to divide this. It's as simple as that. You need to divide this one by the number of centimeters that are there in 1 meter, which is 100, and it will take us back to that one. That is the process that we need to keep repeating. Okay, so let's proceed to the second one. So the scale is given by this, indicating that 1 centimeter on the map represents 50,000 centimeters on the ground. Okay, so if the distance between the two villages on the map is what is it that we've been given now? We've been given the opposite. The distance on the map has been given. Oh, sorry. The distance here, what we have been given 12 centimeters. 12 centimeters. There's nothing that has been squared here. 12 centimeters on the map is what we have been given. Find the actual distance between the two villages. Find the actual distance between the two villages. This one is what we are looking for. When we have 12 centimeters on the map, okay, what is this distance equal to on the ground? Going by this scale of 1 centimeter on the map represents 50,000 centimeters on there. Now this is a basic ratio that we have to, there's nothing like, we don't have, there are no conventions that are involved here. So it's a question of us just, we cross multiply, and then because we're supposed to give our answer in kilometers, you get to discover that at some point we need to, so you cross multiply. 1 multiplied by x, we get x. Then we say 12 multiplied by 50,000. 12 multiplied by 50,000. How do we get to multiply this one? So it's easier if I can say, I hope you're following. It's easier for me if I can say, I put this and then multiply by 5. Okay? We don't want to avoid just, so this will be 0, 0, 0, and this will be 0, and this one gives us what? Another 0, then we have 6. Okay? So what we are getting here, remember, this is centimeters just. We are working with centimeters here. We are working with centimeters. This, I said this is 1 centimeter on the map, 1 centimeter on the ground. This is 12 centimeters on the map. And then even what we have gotten, this answer is when we have 12 centimeters on the map. 12 centimeters on the map is equal to 600,000 centimeters on the ground. This is the number of centimeters that is on the ground equated to 12 centimeters on the map. But the question goes further to instruct us that our answer should be in kilometers. That our answer should be in kilometers. Alright? That our answer should be in kilometers. So what we are supposed to do here now is to look at how many centimeters are there in 1 kilometer. How many centimeters are there? 1 kilometer is equals to 100,000 centimeters. So to bring this one to a kilometer, we need to divide it by the number of centimeters that are there in 1 kilometer, which is 100,000. So we are trying to convert now our answer to a kilometer. So this is what we are going to do. We'll divide this one by, because in 1 kilometer we have, okay, take note of that. When we are dealing with squares, we consider these that have been squared. So now we are going to say our final answer, which is x. Our x now will be this centimeter has to be divided by 100,000 also centimeters, because 1 kilometer is equal to 1,000. 100 centimeters. 100,000 centimeters. So 100,000. 100. Okay, 1,000 centimeters. So we divide there. What do we get? You cancel the zeros. We're going to get 6. Then this 6 kilometer. Okay, 6 kilometers. This is our answer, and I thought that I could demonstrate the first 2 examples just to give you a clue on what you are supposed to do. You are the ones preparing for the exam, and we are trying to facilitate the process. So in that view, I would request that you consider doing the last 3 questions from the same list. Okay, I would consider that this one is drawn. Okay, the only difference here, maybe I can give you a clue on this and this are the same. Even this one, you don't need, these are basically the same. Okay, basically the same. But maybe I can just to try and show you just on one, not as in I'll do the whole lot of it. I just want to show you what is expected of you to do. Okay, so I'm looking at question 3. A plan of a house is drawn to a scale of what? This is a scale 1/20. Okay, then If the actual area, now look at the actual area of the actual, it means on the ground. Okay? The actual, it means on the ground. The actual is what? The actual is what? The actual is this one, isn't it? The actual is meter squared. So the only thing that you're going to see now, we are dealing with something that has been squared. Are we together? We are dealing with something that has been squared. So it means we have to convert both sides, we should do square. But then this one, it's already, these are centimeters. Then this is a meter. So you need to find, please pay attention here. You need to multiply this one, you convert it from this one to centimeters squared. You're going to square this part. Okay? That is what you're going to have here. I think you're going to have 1 over 400. Then this one. Then you have your x. What are you going to get here? You multiply this one. How many? Come here, come here. 1 meter squared is equal to what? 10,000 centimeters squared. So multiply that number by 10,000. When you multiply this by 10,000, you have to add how many zeros here? Okay? You have to add how many zeros? Then you are going to get rid of 2 zeros because of the decimal points that you have. So maybe, I'm sure you're going to get this one. So this is what you are going to work with. This is what you are going to work with. Okay? This is what you are going to work with there. And you go on and find the answer. Okay? Then you do the same thing for... So that is what I thought I should help you do. Please make sure that we do these questions. Make sure that we do these questions. And in case there are those that may want to correct us, you never know. Okay? I can be reached on this number. 09. Okay. That is Mr. Mbondo Shaumba at Nyombayanga Secondary School in Lusaka. Thank you very much for watching. Let's make sure we go through these things. Wait for the next presentation. Okay.